Hello students, today we are going to discuss about atmospheric inversion. Before discussing about atmospheric inversion, let's see what is lapse rate. Lapse rate is the decrease in temperature with respect to altitude. It is represented as minus dt by dz, where T is the temperature and Z is the altitude. Lapse rate is negative because there is decrease in temperature as we go up altitude. For example, when we move from plains to hilly areas, we know that there is decrease in temperature. It means that when we go to higher altitude, there is decrease in temperature. Atmospheric inversion. Atmospheric inversion occurs when the temperature increases with altitude. We have seen in the normal lapse rate that there is decrease in temperature with respect to altitude. But in case of inversion, it is the opposite. That is, there is increase in temperature as we go upwards. This type of lapse rate is called as negative lapse rate. Inversion is an extreme case of stable atmospheric condition. That is, there is no vertical mixing of pollutants with the surrounding atmosphere. So this is a stable atmospheric condition. So to know what is a stable atmospheric condition, we should also know what is unstable and neutral condition. As you can see from the figure on the left hand side, when a pollutant or an air parcel is being emitted to the atmosphere, in case of an unstable atmosphere, the air parcel will slowly move upwards and will get thoroughly mixed with the surrounding atmosphere. That is called as an unstable condition. Whereas in case of a stable condition, a air parcel or a pollutant that is being emitted from a source will have a tendency to sink towards the ground. But in case of a neutral condition, when an air parcel is being emitted, it will have the same temperature and pressure as that of the surrounding, and it will remain at the same place where it has been emitted. To understand more about the stable and unstable and neutral conditions, you can see the figure on the right hand side. That is, when a pollutant is being carried from a valley upwards towards the hilly slope, in case of a stable atmosphere, after reaching at the top of the hill, the pollutant will have a tendency to move downhill on the opposite side. Whereas in case of neutral condition, the pollutant will remain at the level of the peak of the hill. Whereas in case of an unstable condition, the pollutant will have a tendency to go vertically upward and have a thorough mixing with the surrounding atmosphere. The figure here explains the unstable, neutral and stable conditions of the atmosphere in a better way. That is, the unstable condition occurs when there is sunlight or during the daytime. And during this time, the turbulent intensity is very high. That is, there is thorough mixing of the air in the atmosphere. And during this time, the incidence of radiation to the earth is more and the reflection is actually comparatively less. The neutral condition happens either during early morning or during sunset. The turbulence intensity is comparatively less and the incident ray and the radiation being emitted back to the atmosphere is almost balanced. Whereas the stable atmosphere is mainly seen during night time. And during night time, the turbulence intensity is very less and the incident radiation is also less and the heat is more getting emitted to the upper atmosphere. Types of inversion. The common types or forms of inversion are subsidence inversion, radiational inversion, and advective inversion. Subsidence inversion. It is associated with tropical anticyclone. As we know, cyclonic condition means a low pressure area being surrounded by a high pressure area. But anticyclonic condition means it is actually a high pressure area being surrounded by a low pressure area. As you can see from the figure on the left hand side bottom, the inversion layer is the subsidence inversion layer, and in this layer the air is warmed by compression. That is, it is a high pressure area. So the air is warmed by compression, and as the air descends into this high pressure system, it becomes warmer. So in this inversion layer, due to compression, the air in this layer becomes warmer as compared to the air beneath it or the below air. So if the temperature increases sufficient, it sets up a inversion called subsidence inversion. So here you can see that the temperature in the inversion layer is at a higher than degree than the temperature at the lower layer. Radiational inversion. It results from the normal diurnal cooling cycle, that is the day and night cycle. As we know that during the early morning, the temperature of the Earth's surface will be less. But as the sun comes up and as we reach afternoon, the surface of the Earth becomes warmer, and till the sun sets, it will remain warm. But after sunset, the ground cools quickly by radiational heat transfer, and the lowest layer of the air in contact with the surface will lose sensible heat through conduction and mixing. That is, in this case, if you see from the figure on the right hand side bottom, you can see that the temperature of the air just above the surface of the earth is less as compared to the temperature of the air above it. So it sets up an inversion called as the radiational inversion. And this usually occurs just few hundred meters above the surface. Next type of inversion is advective inversion. It is formed when warm air moves over cold surface or cool air. As you can see from the first figure, the warm air from the left side of the hill slowly moves upwards and reaches the peak of the hill. And on the opposite side, on the right hand side, you can see the cool, polluted marine air moving upwards. So as you can see here, there is a inversion setup, that is, there is warm air at a higher elevation as compared to the cool, polluted marine air at the lower level. Another example you can see from the second figure, there is warm air from the land moving towards the ocean, that is towards right side, left side, and there is cool marine air in the form of wind moving towards the coast. The warmer air, it is at a higher elevation as compared to the cool marine air. So again, this is a case of advective inversion. So the inversion may be ground based in the former case and elevated in the latter case. For example, in hilly areas closer to coast, for example, you can see in the third figure, the hill range forces the warm land breeze to flow at high levels, and a cool breeze flows at low levels in the opposite direction, and this sets up the advective inversion. So that's all about the different types of atmospheric inversion. Thank you.